Question number 8 says that a random survey of the number of children of various age groups playing in a park was found as follows. So this is the given data that we have. We have to draw a histogram to represent the data above. From the given data, we can observe that the class intervals have got varying widths. That is, the first class interval has got a width of 1, the third class interval has got a width of 2, and the fifth class interval has got a width of 3. So these different widths, these varying widths, will make the rectangular bars to have varying widths in the graph, and that will give us a misleading picture of the data. So in order to get a good picture and an appropriate picture in the graph, we will have to do some modifications, and the modifications are to be done so that the areas of the rectangles, that is the areas of the bars that we have in the graph, must come proportional to their frequencies. So for that, we will have to adjust the frequency. So to learn how do we adjust a frequency in a given class interval, we'll have another tabular column wherein the class intervals are given and their class widths are given. So the table looks like this. So in this table, we have the age of children in years, number of children associated with each class interval, and the width of each class interval. Now we'll have to adjust the length of the rectangle, that is the frequency of each class interval. So we will first take the class interval with the minimum class width. So 1 is the minimum class width. Now we'll try to divide each class interval into subclass intervals of width 1. So the second one we need not do because its class width is already 1. 3 to 5. In this we can make two subclass intervals, that is 3 to 4 and 4 to 5, each having a class width of 1. Now the frequency for the class interval 3 to 5 was 6, which must get equally divided to 3 to 4 and 4 to 5. So each class interval gets a frequency of 3. So this is how we do it. Now similarly, if we go to the class interval 5 to 7, we can again make two subclass intervals, and the frequency of each subclass interval will be 6 because the frequency associated with the main class interval is 12, which must get equally divided to two subclass intervals. So that basically can be written as, we'll start with the first one. We need not change anything, so the frequency remains 5 as it is. For the second one also, the frequency remains as it is, which is 3. Now coming to the third one, we have the frequency to be 6. So we write it as 6 times 1, which is the class width of each subclass interval, and we divide it by the width of the main class interval, which is 2, and that gives us 3. Likewise, we write for the next one. We write it as 12 times 1 divided by 2, that gives us 6. 6 is the adjusted frequency. Coming to the next one, we write it as 9 times 1 divided by 3, that gives us the answer as 3, adjusted frequency 3. The next one is 10 times 1 divided by 5, gives us the adjusted frequency to be 2. And finally the last one, we write it as 4 times 1 divided by 2, and we get the adjusted frequency as 2. So with these new frequencies, we will construct a histogram and we will get a graph, and then we can understand the whole data that was given to us. So let's draw the histogram. So this is how the histogram looks. We have taken the age of children in years on the x-axis and the number of children on the y-axis, and these are the rectangular bars that we have with the adjusted frequencies. And this is how we solve this problem.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.